All right, finishing up the second half of Unit 4, we're going to continue with the theme of triangle congruence, but now we're going to focus on just certain parts, certain corresponding parts being congruent, and therefore us being able to prove the entire triangle is congruent. Okay. We previously identified congruent triangles as a pair of triangles with all 6 pairs of corresponding parts being congruent. All 6 pairs meaning the 3 sides, 3 corresponding sides, and 3 corresponding angles of the 2 triangles being congruent. Then we were able to state that the entire triangle was congruent to another triangle. But today we're going to focus on 2 postulates that state we don't need all 6 pairs. We actually only need 3 pieces of information. We're going to first start with the property of triangle rigidity, which states that if the side lengths of a triangle are given, then the triangle can only have one shape. So if we were given side lengths of 4, 6, and 7, in order to form that triangle, we're only going to be able to form one. We can't form more than one triangle. So because of that, we have our first side postulate, which states that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. Okay, 3 congruent corresponding sides is enough to prove that the 2 triangles are congruent, and then we could state triangle A, B, C is congruent. Be careful with your congruent statement. If A is in between the 4 and the 7, it needs to correspond to the F, so we would say F, and then B is between the 4 and 6. Whoops. B is between the 4 and, let's finish this statement. Then the 2 triangles are congruent. Great. Our congruent statement was triangle A, B, C being congruent to. A is in between the 4 and the 7, so is F. And then B is in between the 4 and the 6, and so is D. So we would say F, D, E. Okay. Let's use the side congruence postulate to explain why these following triangles are congruent. So let's look at example 1, and then you could try B on your own. We're trying to prove these 2 triangles are congruent. I highlighted the blue and orange triangles because these are the 2 triangles that have the congruent markings on them, right? As of right now, we have 1 pair of congruent corresponding sides, a 2nd pair, and then we actually have this 3rd pair right here, right? PR is congruent to PR in both triangles is congruent to itself by the reflexive property. Okay, another thing you could state here, it's a shared side in both triangles. So because it's a shared side, it has to be the same length in both. And then we could state triangle PQR is congruent to triangle PSR by side congruence postulate. Okay, why don't you do the same for B? Use side postulate to state which 2 triangles are congruent here. Again, there's another shared side, it's AC, and now we can prove that triangle ADC is congruent to, and you could have gone in different order there, but the angles needed to be paired up correctly. A paired to C, D paired to B, and C paired to A by side congruence postulate. Okay, there's also a second congruence postulate we could use that involves two sides and one angle, but there's an important piece of information about that angle. We can show that two pairs of congruent corresponding sides are needed as long as the included angles are also congruent, okay? And the included angle is the angle formed by the two adjacent sides of a polygon. So B is the included angle between sides AB and BC. It's the angle formed by those two sides. So side angle side congruence postulate is also enough information, and we're going to go into more detail why in class. But if two sides and one included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. Okay, and that's what we have here in this diagram. We have two congruent corresponding sides. AB is congruent to FE, and AC is congruent to DE. And then we also have this congruent included angle, one arc on each, and that's enough information to state that triangle ABC, if we start with A, we need to start with E in this triangle because they're congruent. Triangle E, F, D by the side angle side congruence postulate. We don't need to prove all 6 congruent corresponding parts. Just side angle side is enough information to show the two triangles are congruent. Okay, let's try another example. Let's use side angle side to show why these two triangles are congruent. In A, we are told that QP bisects angle RQS. Okay, well, here's angle RQS, and if QP is bisecting that angle, then these two angles would be congruent. That's our definition. If you need a reason, use that sheet. Definition of an angle bisector. And then again, we have a shared side, right? QP is congruent to QP by the reflexive property, or you could state because it's a shared side. And now you have enough information to state triangle RQP is congruent to triangle. If we started with R, we need to start with SQP by the side angle side postulate. All right. Why don't you try B on your own? Go ahead and state which two triangles are congruent after you need to make sure you have two congruent sides labeled in both triangles and an included angle on both. Right now there's nothing marked on here, so you're going to need to do that on your own. Okay, if T is the midpoint of PR, then these two lengths would be congruent. That's our definition of a midpoint. And then you're also told that it's the midpoint of SQ, which means these two side lengths are congruent. Okay, and now you actually have two different pairs of congruent angles triangles, because all of these angles here formed, those are vertical angles. And vertical angles are congruent. It's our vertical angles theorem. So now there are a lot of different triangles you can use here. I'm just going to use the one that's here on the bottom and the one that's here on the top. So I'm going to state that triangle STR is congruent to triangle QTP P by side, angle, side. You could have also used the other two triangles, this one and this one, but for now, those are the two triangles we're going to prove that are congruent. Make sure you have this information labeled, right? Why are these side lengths congruent? Why are these angles congruent? And we're going to have more of an emphasis on that when we start completing some of these proofs. So there's two proofs down here. I'd like to do B with you first, and then you can try A on your own. Let's go ahead and do B together. We're trying to prove, I think it's helpful to highlight the triangles we're trying to prove that are congruent. We're trying to prove that JKL is congruent to MLK. Okay, so overlapping a little bit. You have some given statements here. You're told that JK is congruent to ML. That is given. You are also told that angle JKL, this angle right here, is congruent to angle MLK. That's also given. JKL is congruent to angle MLK. And then we're told KL is congruent to LK. That's this bottom side, which is a shared side. I would almost be okay with you writing shared side, but really we're stating that one length is congruent to itself, which is the reflexive property of congruence. So let's state that. And now you have enough information because you have a side, angle, side in both triangles. So we would state triangle. Actually, sorry, we already have our statement here. Triangle JKL is congruent to MLK because you have side, angle, side congruence information. All right, let's have you finish up trying example A on your own for this proof. Fill in what's missing in the blanks, and we'll go over this together. All right, another given that you have is EG is congruent to FH. EG is congruent to FH. Our next given would be that these two lines are parallel, L and M. And then because these two lines are parallel, we could state EGF, angle EGF and angle HFG are congruent angles because those are alternate interior angles. And the alternate interior angles theorem states if the alternate interior angles are formed by our intersecting parallel lines, those would be congruent. The reflexive property of congruent should be stating a shared side, which would be GF on both triangles. And I apologize, I should have highlighted this earlier. We're trying to prove that this triangle, this purple triangle, EGF, is congruent to this orange triangle, HFG. Okay, but you do have enough information there. You have side, angle, side information on both. So we would state EGF is congruent to HFG by side, angle, side. All right. I think you might have one proof on the homework tonight. Use that reasons to be used on proof sheet. We're going to keep adding to it, and you'll be able to use it on your final. But we'll go over any questions you guys have in class.